All right, in section 3.3, we're going to talk about numerical summaries that serve to be a ranking, okay? A way to show where a data point lines up compared to all of the other data points whenever put in order from lowest to highest, okay? So we are going to specifically be looking at percentiles, okay? And so again, the big picture view here is percentiles help us understand large data sets. Okay, they help us understand large data sets. The most common places to see percentiles is anytime, like if you have kids or a niece or a nephew or somebody and you take them to the doctor, one of the things it'll show you with their height and their weight and when they're young, their head circumference is their percentile, okay? What that's doing is it's telling you how they compare to other kids their same age. When you take standardized tests, okay? Again, this could be like, oh gosh, the STAR test, maybe an SAT, an ACT, basic skills, whatever it is that's out there, okay, whatever school districts are using, you will get a percentile rank. And those are, again, very large data sets. There are thousands upon thousands upon thousands of people taking those tests, or if you're, kids, thousands and thousands of kids that are there for their 24-month checkup or what have you. So that's what it does, okay? So let me tell you what a percentile is, and then I'm going to draw you a picture that will hopefully help make it a little bit clearer, because this is going to look like math speak, okay? So the kth percentile, and I'm just using K as a generic placekeeper, okay? It could mean the 10th percentile, the 15th percentile, okay? Whatever. The kth percentile has, or with, I'm going to say has. That'll be a little bit more grammatically correct here. The kth percentile has k% of the data at or below that value. Okay, at or below. So it could be tied, okay? It could be smaller. So let me kind of show you what this looks like, okay? So let's say we've got all these data values. We've got dozens and dozens and dozens, hundreds and thousands, whatever. These are all the data values lined up, okay? We got millions of them, all right? What that would look like if you were in, say, the 88th percentile, okay? And down here, this is the lowest value, and this is the highest value. If you're in the 88th percentile, let's say that would put you right about here, okay? The 88th percentile would mean that 88% of the values fall at or below you. Okay, if this is you, that's your score. 88% of the data values fall the same or below what you are. That could be your height, it could be your weight, it could be your score on a test, whatever. Okay. Similarly, like let's say you were in the 50th percentile. Okay, you'd be right smack dab in the middle. So the 50th percentile means that 50% of those values are the same or lower than you. Okay, that's what a percentile means. So let's do some interpretation of percentiles. All right, interpret the percentile. So the 5th percentile of the weight of babies 36 months of age, that is 3 years old, but they do still refer them as babies in the health statistics, is 12.0 kilograms. So what does that mean? Okay, that would mean that 5% of all 36-month-old, I'm going to say kids, you can call them babies if you want, weigh 12.0 kilograms or less. Okay, it doesn't mean they weigh 12.0 kilograms. Remember, it's that much or less. The 78th percentile of heights of oak trees is 116.7 feet. So what does that mean? It means 78% of all oak trees are 116.7 feet tall or less. Okay, simple as that. That's what a percentile means.